Hi, Assalamualaikum warahmatullahi taala wabarakatuh, Doctor. We are from group Eva Lenders, and now we are going to present to you about the computer project.
This group consists of 5 members: Nur Akila Shazri, Ikwan Anas, Izina Shuhada, Haikal, and also Abdurawi. We chose an example of slope where a sample of borehole data from site investigation is extracted in order to determine the nature of soil. We designed a slope with a height of 9 meters and is manually calculated and designed using GeoStudio. So the site inquiry begins with its own natural slope. As earthwork progresses, it started to form a new slope. So we need to ensure that the new slope is stable. Developments for new residential areas, roads, railways, drainage, and etc. are prone to erosion from surface water runoff if the slope is not stabilized and the erosion will not be controlled. Uncompacted topsoil, stones, and gravel are subject to wind, rain, and water runoff. It may cause flooding, silt pollution, shifting our unstable slopes, inadequate drainage, and damage to nearby amenities, and ultimately expensive repairs and upkeep.
Problem statement. One of the major challenges during construction come up during managing the operation of cut and fill operations, which are made worse by slope-related problems. In order to reach specified ground levels, the cut and fill method includes the excavation, which is cut, and placing back the soil, which is fill of earth material. Improper slope design can result in instability, erosion, and landslide. It is important that these slope-related problems are resolved in order to protect the project's structural integrity and reduce its negativity to the environment.
Before we do the manual calculations, there are two parameters that we need to find. First, effective stress. Second, angular of frictions. So, from this table, we will obtain 4 layers of soils. Given that unit weight of sand is 22 kN per meter square and PA is 100 kN per meter cube, for depth 1.5 meter, where N60 is 7, the effective stress is 33 kN per meter cube, while the angular of friction is 35.5 degree. Next is at depth 3 meters, where N60 is 6, the effective stress is 66 kN per meter cube, and the angular of friction is 31.4 degree. From these two different depths, we can get the angular of friction for layer 1, which is 33.4 degree.
Hi, I am Abdurawi and I will present our GeoStudio results. Here is our model. Our proposed slope gradient is 1 to 1.5 or 32 degrees, and our slope height is 9 meters. Next is the general output of our model. We use the ordinary method of slices to analyze the slip surface failure. The software has analyzed hundreds of slip surfaces with different center of circles and radius. Here, we can see the factor of safety range from 2.6 to 3 and above. The red colored slip surface represents more critical one. Next is our critical slip surface details. Here we can see for factor of safety 2.261, the radius of the slip surface is 14.6 meter. The center of the curve is at the coordinate of 17.69 and 19.62. The volume of the slip surface is 48.1692 meter cube, and the weight is about 1000 kilonewton. So the software calculated that the resisting force for this steep surface is about 1054 kN, while the driving force is about 466 kN. So dividing resisting force with driving force, we get the factor of safety.
From the previous slide, we will get the value of Ln, alpha n, Wn, C and angular of frictions. For slice 1, the resisting force is 28.54 kN per meter and the driving force is 6.72 kN per meter. And for the factor of safety is 2.26.
Next, I will explain about the conclusion. First of all, JKR has initiate the slope gradient range from the 1 vertical ratio to the 1 horizontal to 1 vertical ratio to the 1.5 horizontal for cut section and 1 ratio to the 2 for fill region in highway construction. Next, the slope design must adhere to the guideline for slope design. According to the JKR specification, all untreated field slope and embankment must have a minimum factor of safety or FOS of 1.3 with a 2 meter berm width and 6 meter berm height. In this project, the slope design was located at the Sekolah Menengah Agama Majlis Agama Islam Wilayah Persekutuan SMA Maib 6, and therefore we choose to provide a natural slope and the FOS value exceeds the JKR criterion with 2.441 and allowing the design to be allowed. That's all from us. Thank you.